Hello and good morning, ladies and gentlemen. Let me begin with the name of Allah, the most beneficent and the most merciful. I am the session chair of this session, session number 11, energy track number 11. My name is Dr. Rabia Shaukat. I am currently working as an assistant professor in the Department of Mechanical Engineering, New Campus, University of Engineering and Technology, Lahore. On the behalf of the organizing committee, I warmly welcome you all in this session of International Conference of Energy, Water and Environment ICEWE 2021. In this session, there are 5 talks. At the end of each talk, we will be having question and answer session. The audience is requested to write the questions in the chat box during the talk. At the end of each presentation, the session manager will ask the requested questions from the presenter. Now let me introduce our session chair, Dr. Muhammad Sultan from Bahauddin Zakaria University, Multan. He is the head of the Laboratory for Energy and Environmental Engineering Research, Bahauddin Zakaria University, Multan. He is the author of 160 plus publications, conferences, books, and chapters. His contact details are provided. Thank you so very much, Dr. Muhammad Sultan, to be with us. Our first invited speaker is Mr. Muhammad Sultan from Bahauddin Zakaria University, Multan. I humbly request you to present your thoughts about sustainable temperature and humidity control option for agriculture applications in Pakistan. Thank you so much.
Bismillahirrahmanirrahim. I am Dr. Muhammad Sultan, working as Assistant Professor at Bahauddin Zakaria University, Multan. The topic for my talk is Sustainable Temperature and Humidity Control Options for Agriculture Application in Pakistan. In this psychometric chart, you can find 4 kinds of temperature and humidity requirements for human thermal comfort. So humans require different temperature and humidity at their office buildings, when they are at classrooms, or when they are at the museums, or different situations. Even humans in different situations require different temperature and humidity. Similarly, for various agriculture applications, we require different types of temperature and humidity. In this slide, you can see some strawberries situation. So the strawberry deteriorate from first stage to 6 stages. So it is due to the inappropriate temperature and humidity conditions. The left side of figure, you can see that different water activity and relative reaction rate. So these relative reaction rates for various options, for example, mold growth, yield strength, and bacterial activities are actually linked with the water activity, which is actually the relative humidity. So we have to provide the optimum temperature and humidity condition for the storage of strawberries. Similarly, if we see this psychometric chart, so here you can find various fruits and vegetable storage zones. So different types of fruits and vegetables require different kinds of temperature and humidity in order to have optimum storage conditions. It's not only related with the agriculture storage, but here you can see the agriculture greenhouses. In the case of agriculture greenhouses, we require evapotranspiration and photosynthesis in both processes. Then water vapors are obtained from the roots of the plant, and these are released into the air in terms of which increase the humidity. So in case of agriculture greenhouses, humidity of the surroundings is always increasing, which need to be controlled. Otherwise, the plant could go in a bad situation and their yield could be affected. So to have optimum agriculture greenhouses, we have to always control not only the temperature but also the humidity in order to have the optimal photosynthesis and evapotranspiration processes. So we need some optimum carbon dioxide and optimum temperature and humidity condition. Therefore, we are always looking for some sort of optimum temperature and humidity control systems. Similarly, in greenhouse air conditioning, in this figure, you can see that these greenhouse grow zones is entirely different from the human thermal comfort zone. So, which actually highlights that it may be possible that whatever we are using for the human thermal comfort may not be suitable for the greenhouse growth. So in our lab at Bahauddin Zaki University, so I would like to share the theme of our research. Usually we are always looking for some kind of low cost, energy efficient and sustainable air conditioning system for agriculture applications. So our theme of the research is mainly divided into two categories for dry climatic conditions and for humid climatic conditions. In case of dry climatic conditions, we usually prefer the evaporative cooling system, which are mainly related with direct evaporative cooling, indirect evaporative cooling, and M-cycle evaporative cooling, and sometimes even it is hybrid evaporation methods. Whereas in case of humid climatic condition as well as humid application, which is most of the cases is the mainly related in the agriculture greenhouses and agriculture product storage, we are usually working for the thermally driven solution that could be absorption cooling and desiccant air conditioning. Here in this figure, you can see a open cycle desiccant air conditioning system. Usually this kind of system has one desiccant wheel and another heat exchanger, and then some kind of a heat regeneration source and some sort of a low cost temperature control units. So usually the air is passed, say you can say the outdoor air is warm, and this is passed from the desiccant, and then it is dehumidified. After dehumidifying the air is passed through the heat exchanger, and then it is sensibly cooled relatively, and then it is passed through the some sort of low cost temperature control unit, that is most probably the evaporative cooling systems. Here you can see is IEC, which is indirect evaporative cooling system, and then it is supplied to the supplier. In order to use this desiccant wheel cyclically, so we have to regenerate this desiccant. So usually the ambient air is again used, or sometimes this is the return air, then it is passed through the heat exchanger and going through the heat source, which is heated up, and then it is regenerating the desiccant, and the moisture, whatever the moisture it has absorbed in the dehumidification process, that has been released in the regeneration process. The above schematics is also explained in the below psychometric representation of the each process. So we have some sort of experimental apparatus for the desiccant air conditioning. This is the one experimental apparatus of desiccant dehumidification system we were using in the in Japan at Kyushu University. So we have kind of polymeric desiccant blocks, and that desiccant blocks is actually placed here, and then air passes from this desiccant materials and then goes to the dehumidification unit, and we could have different kind of experimental condition at different regeneration and operating conditions. That condition actually will lead us to have some sort of input condition for the system analysis. This is another kind of experimental apparatus we have at our laboratory in BZU. So this is a kind of desiccant dehumidification unit. In this unit we have desiccant materials, and there is a kind of arrangement for different air fans and regeneration units. So air is particles, desiccant particles actually absorb the moisture from the air, and then it becomes saturated. After once it becomes saturated, the hot air is passed to remove the moisture from the desiccant material and to use it the cyclically. And in that case, we usually obtain the experimental data for at various ambient air conditions as well as various regeneration conditions. Most of the time we use different kind of materials. In the past we have been using the polymeric sorbents and polymer based absorbents. So in the literature you can find some of the papers which is mainly the material developed by the Japanese researchers, and polymeric solvent 1 and 2. So this materials are like having particle size is about 1 to 20 micrometer. So this kind of 3D images of these materials, so you can see that how this pore size and pore volume exists in these kind of materials. Experimental unit, we also have kind of experimental apparatus which can measure the I mean absorption isotherm and kinetics, and this is some kind of thermogravimetric based absorption measurement unit, which is actually available at the Kyushu University to test. to test the absorption capacity of different kind of material. These are some results of PS1 that y-axis you can see is the absorption uptake and x-axis is the relative pressure and pressure. So this is the relative pressure and this is the pressure side. So these are absorption isotherms you could obtain, and then we usually have to have some kind of modeling. And this is the case for the experiment results for the second material, which is PS2, and you can see that absorption uptake for such materials is relatively like zero point 0.9 at higher situation. So it is really quite good, and which is 2 to 3, 2.5 times of the conventional silica gel. Then we used to have some kind of modeling of this absorption isotherm data. This GAB model we have been using for the relative pressure range of zero point 0.1 to zero point 0.9, whereas for the relative pressure from 0 to 0.35, we usually use the BET model. These are the equations for each model. That model can be used to represent the absorption equilibrium data. Here, these are the optimized model parameters for one. For example, this is the case for PS1. So we usually measure the values of the of each parameter of the model, like BET or GAB model. For each parameter, we usually measure the values at different regeneration temperature, and because in GAB model, this can be represented for the all temperatures. So this is the results for the another material PS2. So here you can see it's kind of different results, and sometimes at relative pressure, at low relative pressure, and the error value is very less in case of BET model, whereas in case of GAB model, sometimes the error value is high. Therefore, if we have to consider the optimized results for low relative pressure, then we usually prefer BET model, whereas in case of high relative pressure, then we prefer the GAM model. So this is the absorption comparison trend for this both material PS1 and 2. So we have plotted these materials, one material in this side, left side, and one material in the other side axis. So PS1 is represented by like a red line and PS2 is blue line. So if we just change the axis, PS1 for right side and PS2 for left side, so you can see it is having the similar kind of behavior. It indicates that some kind of absorption phenomena is almost similar. Dynamic simulation model, in order to have the understanding of dynamic evaluation of the desiccant behavior, desiccant dehumidification behavior, and to have how the moisture is absorbed with respect to time. So we usually prefer the dynamic simulation model. This is the flat plate model, and the desiccant block is shown here, and this desiccant block is actually considered into two layers. One is absorbent layer and air layers, and this is some kind of heat mass transfer balance, and we used to develop equations, and these are equations. About three equations are developed by my professor, which is Miyazaki et al. 2009 and 11 papers. You can find these equations in detail, and there is a modified linear driving force model we use to understand the kinetics of the polymeric solvent, and this equation we use for the simulation of the PS1 and PS2. So these are the results. Not actually, these are the results. This is the outdoor air profile of the different cities like Multan, Fukuoka, Bangkok, and Kuala Lumpur. So how the air temperature and global radiation, air enthalpy, and air relative humidity is changing with respect to the time. So this is just a simple representation of the outdoor air conditions. So there in this slide you can have the parametric analysis that how mass flow rate actually influence the performance. In this above two figures are related to the mass flow rate, and this figure is related to humidity ratio, and this figure is related to temperature. So at different mass flow rate, how temperature profile is changing during the regeneration process and during the dehumidification process, and similarly how humidity ratio is changing during the regeneration process and during the dehumidification processes. Similarly is the case for the humidity ratio and I mean regeneration temperature, and this is also regeneration temperature. Here you can see at 50 or 60 degree 50 and 60 degree regeneration temperature, how humidity ratio and air temperature profile is changing as regeneration process and as the dehumidification processes. This is a kind of switching time and switching interval optimization that at different cycle time. For example, here like 120 to 120 means 120 dehumidification and 120 is regeneration. So regeneration versus dehumidification time intervals. So however we should have to switch the desiccant blocks from dehumidification to regeneration mode. So such kind of optimization is required. So you can see that in the green case 30 to 30, if we have low time limit, so in that case we may not have high deep dehumidification, but if you want to have deep dehumidification, you have to have increased the cycle time for the dehumidification process. So this is the case for the system performance. So here in the y-axis, you can see that dehumidification may study supply air enthalpy for the different weather conditions like Multan, Fukuoka, Kuala Lumpur, and Bangkok. So you can see at a different regeneration temperature, we could have different kind of dehumidification capacity as well as the supply air enthalpy. System COP. In this figure, we have calculated system COP for PS1 and only for PS1 because the PS2 results were not that good. And therefore, we just realized that we might just show the results for PS1. So here you can see that the system COP, the function of regeneration temperature for the PS1 materials. So COP is like kind of 0.5 nearly, and it is changing with respect to the not only with respect to temperature but also with respect to day and night time as well as the climatic conditions like Fukuoka, Multan, and Kuala Lumpur are the Bangkok. Why we choose these four cities? Because this Kuala Lumpur and Bangkok is really humid conditions, whereas the Multan and Fukuoka are relatively moderate conditions. The system COP comparison you can have here. So how these conditions, Multan, Fukuoka, Kuala Lumpur, and Bangkok is changing with daytime and nighttime. Two figures for day one is daytime and another is the nighttime. So you can see that different kind of performance is achieved. Whereas in case of in daytime, highest COP was obtained by the Fukuoka, followed by the Kuala Lumpur, and the worst situation was in case of the Multan. Whereas in case of nighttime, highest COP was obtained again by the Fukuoka, whereas the lowest was obtained by the Bangkok. So it is because of the available humidity limit. That's all for my talk, and I am open for questions if any. Thank you so much.
Thank you so very much, Mr. Muhammad Sultan. If the audience has any questions, please paste your questions in the chat box. Thank you so much, Dr. Muhammad Sultan, for your presentation. This question, like, will these control systems will affect the price of our agriculture products?
Yes, thank you for the important question. Yes, obviously this will affect the price of the product and it will slightly increase actually. But as far as if we see the storage time and other things, that is usually 1 month to like 2 months, which can be extended from 3 to 6 months. So in other ways, we can increase the product price that can easily cover the operating cost of the system. So this at the end, the economics of the product will not disturb, even it will be more beneficial.
Thank you so much, Dr. Sultan. There are other questions as well, but because of the lack of time, we cannot continue the other questions. Thank you so much once again. Thank you so much. Now our next presenter is Mr. Muhammad Asif from Punjab University, Lahore. I would like to invite him to present his work on investigation of kinetic and thermodynamic parameter of Sapodilla leaves pyrolysis by using Coates Redfern method. Thank you so much.
Hello, Assalamu alaikum. I'm Mr. Asif from Institute of Energy and Environmental Engineering, the University of the Punjab. I have to present on the topic the investigation of kinetic and thermodynamic parameter of Sapodilla leaves pyrolysis by using Coates-Redfern model. Pakistan has a limited for energy resources of fossil fuels, but it has a huge potential of renewable energy resources like a solar energy or a biomass energy. Pakistan is producing several tons of biomass waste every year, but there is no proper setup for energy production from these biomass wastes. In this research, we targeted on energy production from garden leaves, specifically from Sapodilla leaves, which is producing in a huge quantity every year in Pakistan and going to be wasted. And this may be a useful source of energy production at domestic levels in Pakistan. For this process, we uses the protocols like shown above. First of all, we have collected a sample from Chico Gardens. After their cleaning and drying, the sample was grinded into 250 micrometer sizes, very fine size that is according to the ASTM standards. Sample characterization was performed by approximate analysis in which its moisture content, volatile matter content, ash content, fixed carbon content was measured. In ultimate analysis, its carbon content, hydrogen content, sulfur content, nitrogen, and oxygen content was measured by using elemental analyzer. And after that, its higher heating value, gross calorific value, was measured by using a bomb calorimeter. After that, its TG thermogrammetric analysis was performed at 4 different heating rates, 10, 20, 30, and 40 in inert atmosphere with the nitrogen flow of 3.5 liter per minute. And after that, from TG analysis, its kinetics and thermogrammetric parameters was investigated by using different models. Its proximate analysis shows very good results and shows about 87 to 88% of combustible material. That is a very good agreement. And its ash content is very lower, even that for some good quality coals. And moisture content is also in permissible limit for the utilization of this biomass. Due to the good proximate composition, it shows a calorific value about 23.39 megajoule per kg. That is even better than some good quality coals in Pakistan. Its ultimate analysis shows that it has a higher percentage of carbon and hydrogen, and sulfur is also very minor amount. That is also very less than that of the threshold limit, permissible limit of EP, that is about 1% in solar fuel, should be acceptable. But there is a problem of its nitrogen content that is very high, but this problem can be resolved by using some thermal low temperature NOx burners or catalytic conversion for the NOxes. And so there is a technology available for tackling this issue. And so it can be used for energy productions in Pakistan. From thermogrammetric analysis, its kinetics and thermodynamic parameter was investigated. For kinetic analysis, the basic equation was used. That was Coates-Redfern model is given in this slide. In this, this equation was compared with the accurate equation, that is a equation of straight line y is equal to mx plus c, Here y is log natural GFL power t square and x is 1 over t. And slope E activation EA over R is a slope, that is M, and remaining part is uh, C. In this, M is activation energy, that is EA over R, that is the activation energy, and log natural AR over beta activation energy into 1 minus 2RT over EA, that is collision frequency. Here A can be calculated uh, by using simple mathematical relations. These 10 sub-categorized models and 5 major models was used for investigation of a proper degradation models that obeys in the thermodegradation of Sapodilla leaves, chiku leaves. Because of that, in the most of the research papers, it was observed that uh, most of solid state degradation reactions falls in the category of these 5 major reactions. So we also follow these reactions. Thermodynamic parameter was calculated using these basic equations, in which enthalpy, Gibbs free energy, and entropy was calculated as given in the slide. Its thermogrammatic analysis shows that it has a 3 different degradation curves. First curve showed that about at 100 to 110 shows removal of moisture content, and after that 230 to 450, 440 that represent the evaporation evolution of volatile matter content, lower hydrocarbons, and after that the steeper slope shows that the degradation of heavy molecular weight substances, and at the end there is some amount of biochar also present. Because of that, this destruction occurred in a inert atmosphere. Its kinetic and thermodynamic analysis shows that the diffusion model D3 shows a better result for linear regression coefficient. It has activation energy in the range of 9 or 10, and it shows a regression factor highest among all the remaining other models. Its activation, its thermodynamic calculations also shows that energy should be required for the initiation of reactions, and anisotropy shows that the product is in well-ordered form. In higher temperature degradation reactions, the nucleation model shows that it is a suitable model for the degradation of Sapodilla leaves, chiku leaves, and that shows the highest regression coefficients. Both subcategories are also good for higher temperature degradation of Sapodilla leaves. And similar trends like that of lower temperature and higher temperature, the similar trends of thermodynamic parameters was also observed. That it has a negative value of entropy shows that product is in a well-ordered form, and enthalpy, positive value of enthalpy showed that energy is required for the initiation of a reaction. But the one point major among the low temperature and high temperature degradation, that there is an activation energy is lower with the higher temperature, and the change in enthalpy is also lower with the higher temperature, with increasing temperature. Conclusion. Conclusion showed that diffusion model in lower temperature regime and nucleation model in higher temperature regime showed better regression coefficient as compared to chemical reaction order, phase interference, and Forward's law that we have used. Della shows that positive value of all the reaction mechanisms showed, which indicate that the energy is required from external source to convert the Sapodilla leaves into activated complex. Mean energy is required for the conversion of reactant into product. For the degradation of process, energy should be required. The reaction mechanism model showed lower magnitude of Gibbs free energy at different regime of temperature and different heating rate indicate that degradation of Sapodilla leaves may be occurred at lower temperature. Negative value of del S also confirm that product in a well-ordered form, and this due to a higher content of volatile matter and higher activation energy in lower temperature regime. This biomass should be utilized for its conversion into bio-oil or biogas production. It is a suitable biomass. If in the futures, how we can work on that. Uh, thank you. References in this: Professor Dr. Hamid Star and Professor Dr. Shahid Munir and Professor Dr. Salman Naqvi. I acknowledge all of them in my this research because I used protocols given in the paper of these researches, and I got help from these also. Thank you. If you have any questions, please you can ask me.
Thank you so very much, Mr. Muhammad Asif. If the audience has any questions, please write it into the chat box. Thank you.
I am Hafiz Sifat.
Now I would like to invite Hafiz Saab from Bahauddin Zakaria University, Multan, in order to present his work on the performance evaluation of evaporative cooling options for livestock thermal comfort. Thank you so much.
Bismillahirrahmanirrahim. I am Hafiz Sifatullah from Department of Agricultural Engineering, Bahauddin Zakaria University, Multan. And my presentation topic is performance evaluation of evaporative cooling options for livestock thermal comfort. These are the contents of my presentation that includes the problem statement, research objectives, types of air conditioning technologies, materials and methods, results, and discussion and conclusions. Problem statement. The livestock sector is the major contributor of agriculture as compared to the crop productions. The thermal comfort of livestock is highly affected by the heat stress. As compared to the humans, the animals have different metabolism and the respiration rate. The milk productions and the meat production of animal is highly affected by the heat stress conditions. So there is necessary to provide the thermal comfort zone for the animals. This is the psychometric representation of thermal comfort zone of the livestock. The thermal comfort zone of livestock ranges from 5 to 25 degrees centigrade. If the temperature increase or decrease from the thermal comfort zone, it results the heat stress conditions. The heat stress condition results the decline in milk productions and meat productions. So the objectives of our study is to evaluate the optimum temperature and humidity for the thermal comfort of high productive cattle breeds such as Holstein Friesian, and to investigate the evaporative cooling options such as direct evaporative cooling options, indirect evaporative cooling options, and mesocycle evaporative cooling options for the thermal comfort of foreign cattle breeds in the climatic conditions of Multan, Pakistan. So the evaporative cooler is a device that cools the air by the evaporation of water. The evaporation of water causes the cooling effect, which is due to the heat of water vapor evaporation that causes the changing the phase of water vapors. The evaporative cooling system mainly includes the wet bulb cooling and the dew point cooling. A direct evaporative cooling system. It is the oldest form of the evaporative cooling options. In Pakistan, it is also known as warm cooler. The direct evaporative cooling system states that in this system, the air and water is in direct contact. The direct evaporative cooling system consists of the water tank, water pump, sprinkler, cellulose pad, and the fan. The warm air enter from the one side of direct evaporative cooling system into the cellulose pad, and the water is pumped from the water tank and goes into the cellulose pad through the sprinklers. Here the air and water is direct contact, and the cool air is then out from the other sides. This is the psychometric representation of the indirect evaporative cooling systems. From the psychometric representations, we see that in this system the enthalpy is remain constant. The direct evaporative cooling system is an adiabatic system. In this system, the temperature reaches up to the wet bulb temperature. This is the indirect evaporative cooling system. The indirect evaporative cooling system is an advanced form of direct evaporative cooling system. This system consists of two types of channel, wet channel and the dry channel. In this system, the air is passed through from outside into the channel. First, the air is passed through the dry channel. The air has a temperature, and the air has the temperature, and from the wet channel from which the water is passed through, the water evaporates into the surface of the dry channel and the air becomes cold, and then the air is out from the then this air is used as the product air. In the direct evaporative cooling system, the temperature reaches up to the wet bulb temperature. In direct evaporative cooling system, there is no direct contact of air and water. And the M-cycle evaporative cooling system. The M-cycle evaporative cooling system is also known as dew point evaporative cooling systems. And this it is a concept that captures energy from the air by utilizing psychometric renewable energy available from the latent heat of water present in the air. This system consists of two dry channel and one wet channel. The air is passed through from the dry channel, and the water from the wet channel evaporates and to the up to the surface contact of the dry channel. The air that passed through from the dry channel, its temperature decrease, and then it goes out from the other side. This process takes place again and again until the temperature reaches up to the dew point temperature. And this is the psychometric representation of M-cycle evaporative cooling system. In M-cycle evaporative cooling system, the temperature reached up to the dew point temperature. These are the merits and demerits of evaporative cooling options. The advantages of evaporative cooling option is that this is the low cost and the energy efficient systems, and this can be easily made and maintained from the locally available material, and it reduces the up to 70% of primary energy use, and this is applicable for the short-term food storage and also for the buildings. And the disadvantages of evaporative cooling system is that it requires the constant supply of water, and this system only works on the daytime, and the performance of the direct evaporative cooling system mainly depends on the ambient air conditions, and this system is only suitable for hot and dry areas. And for this system, the ventilation is also required from the outside of the system. The research methodology: in this we calculate the wet bulb effectiveness, dew point effectiveness, and the THI. The wet bulb effectiveness is the difference in inlet and outlet temperature to the difference in inlet and the wet bulb temperature. The direct evaporative cooling system and the indirect evaporative cooling system, we also measure the wet bulb effectiveness. And the dew point effectiveness is also the difference in temperature, inlet temperature and outlet temperature to the inlet and corresponding dew point temperature. And the dew point temperature is calculated from these equations. The dew point temperature is the temperature to which air would have to cool in order to reach the saturation. And the temperature humidity index, it is the relation of temperature and the relative humidity. And the relative humidity is defined as the amount of water vapor present in the air expressed as the percentage of amount of water for saturation at the same temperature. These are the results and discussions. In the slides, we shows that the variation of temperature and relative humidity at ambient conditions and from the output conditions of the DEC, IEC and MEC for the whole years. As we see that the ambient, if the temperature increase, the relative humidity also decrease. From the figure, we can also see that the direct evaporative cooling system gives a temperature gradient of 6 degrees centigrade. These are the temperature humidity index. It is the variation in the temperature and humidity index from the ambient conditions and from the evaporative cooling options such as M-cycle evaporative cooling options, DEC and IEC system. If the THA is between 68 and 72 is reliable for the livestock thermal comfort. If the temperature humidity index increase or decrease from 68 to 72, it results the heat stress conditions. This figure shows the variation in wet bulb and dew point effectiveness. As we see that the effectiveness of direct evaporative cooling system reaches from 0.9 to 0.95 degrees centigrade. And the effectiveness of indirect evaporative cooling system reaches from 0.45 to 0.55, and the effectiveness of the M-cycle evaporative cooling system reaches from 0.75 to 0.85. This is the feasibility of evaporative cooling options for the livestock thermal comfort for the whole years. As we see that the ambient conditions are not best for the Holstein Friesian cattle for the month of April, May, June, July, August and September. And we see that the M-cycle evaporative cooling system is the best options for the livestock thermal comfort, except for the month of July and August. Due to this, these are the monsoon season in Pakistan. On the other side, the direct evaporative cooling systems is also best for the livestock thermal comfort, except these months, June, July, and August. And the evaporative cooling options are not feasible for the livestock thermal comfort because the month of January, February, and April, there is no need of the air conditioning. And for October, November, and December, these months are also no need for the air conditionings. Conclusions. The conclusion of this study is as follows. The evaporative cooling system perform better results in hot and dry regions, and the applicability of evaporative cooling system is limited during the monsoon seasons. And from the result, we see that the M-cycle air conditioning system give better result as compared to the other evaporative cooling options. From the result, we can also see that the ambient air temperature was ranged from 27.1 degrees centigrade to 35.0 degrees centigrade. And the result displays that the direct evaporative cooling system gives the cooling effect from 6.4 to 10 degrees centigrade, and the indirect evaporative cooling system The cooling effect was ranging from 3.9 to 6.7 degrees centigrade, and MEC, Maslenko cycle evaporative cooling system, the cooling effect was ranged from 5.3 to 11.6 degrees centigrade. And thank you for your kind time.
Thank you so very much, Mr. Hafiz, for your presentation. If the audience has any questions, please write them into the chat box. Thank you so much. Thank you so much, Mr. Hafiz. There is one question, like which system is currently using in Pakistan for thermal comfort control of poultry and livestock?
Thank you so much for your kind question. And in Pakistan, the desiccant air conditioning system and the direct evaporative cooling system is mostly used for livestock thermal comfort and for the poultry air conditioning.
Thank you so much once again.
Thank you.
Our fourth speaker is Mr. Muhammad Asjad from NUST. I would like to invite him to present his work on comparison of thermophysical properties of fatty acids using temperature history method and differential scanning calorimeter for thermal energy storage applications. Thank you.
Assalamu alaikum. Myself Muhammad Asjad, and my presentation topic is comparison of thermophysical properties of fatty acid using temperature history method and differential scanning calorimeter for thermal energy storage application. And two other co-authors are Dr. Majid Ali and engineer Azim Servers, and our affiliation belong to USPK's NUST, Islamabad, Pakistan. As we know that the Pakistan have to face energy crisis. The 84% of world energy consumption are rely on the fossil fuels that cause the adverse effect on the environment, like carbon emissions, air pollutions, and also cause the fossil fuel depletions. The researcher provide a solution of this problem in the form of the renewable energy resources. There are different types of the renewable energy resources are available, but few of them cause the sustainable challenges. The solution of these problems can be provided in the form of integration of energy production system with energy storage system. There are different types of the energy storage methods and material available to store the thermal energy. Materials and method. Thermal energy storage methods can be categorized into physical storage and chemical storage. Physical storage further categorized into sensible heat storage and the latent heat storage. Latent heat storage has more than 10 times higher energy density and then sensible heat storage and phase change material are belong to the latent heat storage method. There are two types of the phase change material are selected for this research. First one is the stearic acid and second one is the palmitic acid. According to the objective of this research, we will compare different two methods, thermal characterization method. First one is DSC to find out the thermophysical property of these two phase change material. First one is the thermal characterization using DSC. And DSC 250 TA apparatus instrument are used for this purpose. And this analysis tests the endothermic and exothermic heat flow. In this experiment, we can choose the 25 to 80 degrees centigrade temperature for endothermic test, and in the case of exothermic test, the temperature was 80 to 25 degrees centigrade. And this analysis method is used to find out the latent heats, melting and solidification temperatures, and specific heat capacity. It can also find by using standard test as I mentioned here, ASTM E2165-11. So these thermophysical properties can be find for this method. In the now we move toward the thermal characterization technique number 2, that is the T-hysteric methods. The experiment setup of these methods are present here. These are the test tubes first one contain the distilled water as a reference material, and second one contain the phase-in materials. And each test tube contain the thermocouple to record the temperature with respect to time. And that is the high temperature water bath, which is maintained at 80 degrees centigrade, and this is the low temperature bath, which is maintained at 10 degrees centigrade. And these are thermocouple also used to record temperature with respect to times. These four thermocouple are connected with the multi-channel data logger, which is used to save the temperature with respect to time, and then we extract the temperature from this data logger and present in the form of the two type of graph. One is the charging graph curves, and second is discharging curves or graph. When we put this assembly into the high temperature water bath, then the phase material is transferred into a liquid form, means the melting process is start, and the temperature of this phase material is changed with respect to time and recorded here. And then we extract data from data logger and present the graph in the form of charging curve. When we put this assembly into the low temperature water bath, then the melted phase material is transformed into the solid form. In this way the temperature also change, means when the temperature of the phase material is become lower and saved in the data logger, we extract this temperature from this data logger and we present in the form of discharging curves. Now we move toward the results. The DSC curves and result means the result obtained from the DSC analysis are present here. This is the DSC curve for stearic acid, and this one is the DSC curve of the palmitic acid. The above curve shows the charging or discharging process, and lower curve shows the heating or charging curve. Similarly, upper curve shows the cooling or discharging process, and lower curves shows the heating and discharging curves. And this point is the peak temperature, and this is the onset and offset temperature. In this way, similarly, the data we obtain from this graph is and present in the form of the values here. This is the stearic acid and palmitic acid, or corresponding the charging and discharging value like temperature, onset, peak end temperature, and then we calculated the latent heat of each form by using the software, DSC software, and behind the formulation behind this DSC software was the area under the curve. Then we calculate the latent heat. Now we move the second part of the result, that is obtained from the experimental setup. This is the charging curves. The blue color shows the charging curve of stearic acid, and red colored curve shows the charging curve of the palmitic acid. In the start, the charging very fast due to the very high temperature difference. And then in this portion it shows the phase material, and this one is also becomes straight due to the low temperature difference between the distillated water and the phase materials. And this here stored the sensible heat, and at the phase material the latent heat storage, and again the sensible heat storage. Now we move toward the discharging curves. The first one shows the discharging the curves of the stearic acid, and second one is the palmitic acid. And the first this portion is shown to the liquid region, and this is the phase change region, and this is the solid region. Similarly, liquid region, phase change region, and the solid region. And here was the sensible heat release, and in this portion the heat only the latent heat are released, and again the sensible. This is the discharging curves of the two phases. By after using the formulations, and we obtain the values of the stearic acid and palmitic acid, like melting point, latent enthalpy, and specific heat in the liquid form and in the solid form. And a plus minus shows the uncertainty of the experimental setup, because each experimental setup have some uncertainty which are also added in the values. Conclusions, and this research work concludes following points. First one is that T-Histing method is one of the convenient, no doubt is very convenient and very cheap method and reliable method for calculating thermophysical property of fatty acid. this is very reliable because it shows very small error with literatures and DSC results. When we compare the t-heuristic method with the DSC result, the only 1.52% in the case of stearic acid and 0.70% in the case of palmitic acid, relative error in the values of melting points, and in the values of latent enthalpy, the relative error was only 0.69% in the case of stearic acid and 2.96% in the case of palmitic acid. When we compare the t-heuristic method result with the literature, as mentioned in the reference file literature, to obtain the value from the literature. Now, the relative method, the relative errors in the melting points was very small, 0.28 for stearic acid and 0.67% for palmitic acid. And in the case of latent enthalpy, this relative errors was in the case of stearic acid 0.21% and in palmitic acid 4.86%. So this research work shows that the t-heuristic experimental method is one of the best and reliable method, and it shows very small error with the DSC and literature values. Acknowledgement, my own department, NUSTEM, USP case, and I acknowledge this research work to my principal, supervisor, lab engineers, and I did this experimental work with the sponsorship and with the help of the USAID scholarship. This is the reference which is used to extract the literature values of the melting points and latent heat enthalpy of the stearic and palmitic acid and other sources.
Thank you so very much, Mr. Muhammad Asjid, for your presentation. Now, I would like, if the audience has any questions, please write them into the chat box. Thank you so much, Mr. Muhammad Asjid. We have got one question from you for you. Like, what is the application of these fatty acids, where they can be used?
Thank you so much for this valuable questions. Actually, fatty acids are used as a fisting material, can be used to store the thermal energy like domestic and commercial applications. Thermal energy also store when we extract the renewable energy and then store into fisting material as thermal energy. And this thermal energy is further used for the human comfort, as mentioned before, like domestic and commercial applications.
Okay, so they will be used as a phase change materials. Thank you so much. Thank you.
Thank you, ma'am.
Thank you so much. I would like to invite our last speaker, Mr. Hamza Latif from UET New Campus, Siraj, in order to present his talk on achieving sustainability in the Academic Institute of Pakistan via implementation of SDG 6 and 7A case study of GCU Lahore. Thank you so much.
Assalamualaikum. My name is Muhammad Hamza Latif and I'm working as a research officer in Alternate Energy Research and Innovation Lab, UT Lahore. It is such an honor for me to present my work in International Conference on Energy, Water and Environment. The topic of my research is achieving sustainability in the academic institutes of Pakistan by the implementation of Sustainable Development Goals 6 and 7, which is a case study which took place in GCU University, Lahore. Quickly moving forward towards the brief background of our work, we know that Pakistan is an emerging country, and over the past few decades, we have faced some heavy industrialization. Due to limited natural resources and economic constraints, this has led to a massive energy crisis in Pakistan that has led to high load shedding across the country. So this study basically highlights the gray areas and the implementation of sustainable development goals to cater these issues in Pakistan. The application of this research mainly lies in the field of energy and water efficiency in industry, academia, and public sector buildings. This is the overview of Sustainable Development Goals introduced by the United Nations. There are total 17 SDGs introduced by UN, which basically focuses on the economic conditions of the world, the social conditions of the world, and the social well-being. These 17 encompasses all the aspects of life and focus to improve the overall quality across the world. The two SDGs which we have targeted is the SDG 6, that is clean water and sanitation, and SDG 7, affordable and clean energy. So, moving towards the design method and materials, we have compiled or consolidated our entire activity in 4 phases. The first phase is pre-retrofit setup. So this is the definition of the work scope when we identify the target area and we set the project targets which we have to achieve. We have to determine the available resources and we have to conduct a pre-retrofitting survey to make sure that the actual conditions depict the scenario or not. The phase 2, which is the energy audit, we identify the KPIs and we conduct the on-site energy audits. Phase 3 is the identification of retrofitting solutions that have to be taken place on that site. In this phase, we estimate the potential of energy saving. The old appliances are replaced with the new appliances, and retrofitted options are then analyzed in the sense of cost, benefit, and ROI determination. Phase 4 is the determination of solar potential and PV system analysis. In addition to that, the phase 4 also encompasses the SDG 6, that is clean water and sanitation. We estimate the overall consumption of the water, the energy required to pump the water to the overhead water storages, and the overall reduction we can bring in via the implementation of SDGs. So this is the method and material we can say that we have identified the retrofitting solution in the terms of lighting load, in the terms of air cooling load, in the terms of PC load, in the terms of air conditioning load. We have replaced the old inefficient loads and lights in this particular case with efficient lights. As you can see, we have replaced the retrofitting solution. These solutions have been carried out after the simulation on Dialex tools so that the lux level of that certain area doesn't fall down from the recommended levels as recommended by the international associations. In case of the ceiling fans, we make sure that the needs are catered, and for the CRT-PCs and air conditioners, similar activity has been followed. So, concising the results, we see that the overall load, lightning load before the retrofitting was 321 kilowatt, and that was reduced to 128 kilowatt, which showed a percentage reduction of 60%. That is a very, very huge figure. In this air cooling load, the reduction figure has been around 40%, and for the air conditioning load, the reduction figure has been around 9.91%, which can vary from case to case and institute to institute. So if we cater, if we see the overall scenario, we see that a 24.47% reduction has been observed in the entire case study. This has been depicted in the form of bar graph to indicate that before the retrofitting, the load was quite high. After the retrofitting practice, this was the load and this was the amount of percentage reduction that we have achieved. So this shows a very healthy results that can be implemented and can be replicated to the other institutions as well. This is the before retrofitting results and this is the after retrofitting results. And moving forward, the solarization potential of the GCU University was found to be around 850 kilowatt, keeping in view the constraints of injection points. And the proposed model is ESCO model, in which the energy service company will come and invest and will sort of rent out the entire system, and the university will pay a minimal price for the per unit generated by the PV system. And it is estimated that keeping in view the overall rooftop area and by the calculations, we have estimated that approximately 50,000 gallons can be conserved during the rainy seasons of the year, which can be increased further by the increment of the overall underground water storage. So last but not the least, after giving a brief scenario of my study, I would like to point out why we are focusing towards the Nexus implementation and how Nexus implementation helps us effectively utilize the resources. Basically, in Pakistan or across the world, we see that if we cater to the problems individually, the resource allocation is very high for the individual work to be done. So what we have identified is that if we implement the sustainable development goals in a nexus form, like we have done in the form of SDG 6 and SDG 7, we can reduce the overall costs and we can reduce the overall allocation of the resources, which can lead to an effective implementation of the sustainable development goals. And in the end, I would like to acknowledge Al-Khwarizmi Institute of Computer Science and PICA for the support in the study. PICA and Al-Khwarizmi are collaborating for the energy audits, and it is the aim of Government of Punjab to conduct energy audit of all the public sector buildings and to carry out retrofitting and in the latest stages water conservation and installation of solar PV systems. So thank you. That's all from my side. If you have any question, you're free to answer. Thank you so much.
Thank you so very much, Mr. Hamza Latif, for your presentation. If the audience has any questions, please write them into the chat box. Thank you so much. On the behalf of the organizing committee of ICEWE 2021, I am thankful to the session chair, Professor Dr. Nadeem Ahmed Mufti, our invited speaker, Dr. Maqsood Ali, all the distinguished presenters and the participants. It was a wonderful session and I hope the audience had enjoyed it. Hope to see you all in the next session as well. We have other sessions running in parallel and the industrial exhibition also showcased on our website. So enjoy our exhibition and parallel sessions. Thank you once again for sparing time for this productive session. Thank you so much.